like choices of health and lifespan should, as much as possible, be for individual people to decide. And if they want to live 150 years and no longer, fine. If they want to live 80 years and no longer, that should be up to them. But it's really a matter of giving people choices. Now, it might seem to people who are in their 20s and 30s and 40s that when they get to their 80s, they'll be like, well, I've done everything I set out to do and I'm finished with life. But if you actually go and you survey those who are terminally ill, you go into hospices, you find people who are sadly dying of cancer, and you ask them, like, what is your will to live? What you will see is that I think something like 70% of them in surveys that have been done still describe having a very strong will to live. And I think that's because for most people, whether they're 80 or probably even 100 or 120, if you give them the option of another day in the sun with their relatives and some music and some ice cream or whatever else they enjoy, or if you give them more time to pursue their goals and their passions, people would generally like to live longer lives than we currently do.
Dr. Ariel Zeleznikow of Johnston is a neuroscientist, currently a research fellow at Monash University in Australia, and the author of the outstanding book, The Future Loves You, How and Why We Should Abolish Death. Ariel, welcome to the show.
Thanks very much for having me.
Well, just what a thoroughly enjoyable and thought-provoking book. So much to talk about, but I thought it would perhaps be best if we begin this conversation with a story that features in The Future Loves You, and that's the Elizabeth Hughes story. Why is she relevant here?
Yeah, so the book, in very brief, and we'll get into it, is about medical progress and the possibility of being able to live just long enough that a treatment is developed so that one can live longer. In the case of the book, I'm talking about weird sci-fi stuff like brain preservation and mind uploading and that sort of stuff. But I think to start off with, it's worth thinking about the development of medical treatments we take for granted today that once upon a time were themselves science fiction. So I start this book with the story of Elizabeth Hughes, who in 1919, at the age of 11, was diagnosed with what was then called juvenile diabetes. And at the time, there was no insulin. We didn't really know what caused diabetes. And the prognosis, the survival for someone in her circumstance, was only a few months. So basically everyone else who developed diabetes died shortly thereafter. Now, Elizabeth's parents were understandably very upset at this prospect, and they went looking for anything they could do to try and help save their daughter. Now, they didn't come across insulin because it hadn't been discovered yet, but what they did come across was one weird and new therapy that had been invented, which was starvation therapy, which was the practice of taking diabetic children and feeding them only just enough food so that they didn't starve to death. But in doing so, reducing the ill effects of having too much sugar in the blood, which is what happens in diabetes, and thus stopping things like getting acidic blood and other complications of diabetes. So Elizabeth was kept in this starvation-like state, just teetering on the edge of being alive. But as a result, instead of dying after a few months, she lived for a few years in this way. And then in 1921, when insulin was discovered and did become available, she was able to receive it and then gain back her weight, gain back her health, go on to go to university, to get a job, to have kids, and live into her 70s. So as a result, it's incredible, this progress, that she just lived long enough to make it so that she could make use of this new technology. And I think it's a good example of how, unprecedented circumstances, somebody suddenly not dying from a disease that up until that point killed everyone who had it. Sometimes things really do change.
So would you say that, I guess that's what you're saying, that we're at the precipice of a similar kind of event when it comes to, I kind of don't want to say immortality because it makes me feel like we're discussing Highlander or something. But yeah, in a way, abolishing mortality.
Well, yeah. So, immortality is a big term, and I avoid using it because obviously I don't think there's any proposal anyone has that could make someone be totally immune to the forces of destruction that exist in the world, whether that's car accidents, whether that's nuclear war, whether that's the eventual heat death of the universe. Like, there's plenty of things out there that can get someone. But what I think is relevant from the Elizabeth story is it's an example of somebody surviving long enough to make use of newly developed medical treatments so that they could then live longer into the future. And what I talk about in my book is the prospect of maybe being able to take people who are dying today and preserve them in some way, shape, or form, such that they're able to be revived in the future once future medical advances can fix whatever it was that caused them to be dying in the first place and restore them to health that way. And hopefully through doing so, give them considerably more time, as much time as is practical and as that they would want to take up.
Okay, let's just jump right in. How would preservation work? What's the idea or the mechanism behind this process?
Yeah. So weird sci-fi idea, right? Like people have probably come across it in movies or books, this idea of taking someone, putting them in a cryopod or stasis or something where they're unconscious and unchanging for, I don't know, some duration of time, a year, 10 years, a century. And then at the end, they come out and they're like basically the same as when they initially went in. That's the notion in science fiction. But the question I wanted to ask with this book is like, is anything like that actually possible? And if it could be made possible, like what would be real and what is hype and what would the constraints be? That's the set of things that I work through over the course of the book. So it's a science fiction idea, but it does have some precedent from the natural world. So we see, for example, there's a kind of frog called the wood frog that lives in the Arctic. And each winter, most of its body freezes, its heart stops, its brain activity stops, but then come spring, it thaws out and it goes back to hopping around. So that's one example of how something like this works. Or another example, even with human biology that we use today, is the sort of preservation methods we use for storing sperm and eggs and embryos that are used in IVF procedures, where what happens is you can take these groups of cells or individual cells and you can cool them down to really low temperatures, and through doing so, essentially stop biological and chemical time. What's fascinating about that is the technology to do that has improved quite a lot over the past few decades as well. So initially, people tried naive ideas of just like straight freezing biological material, just like cooling it in liquid nitrogen. And that kind of worked, but it causes some problems where just straight freezing causes ice formation. So you get these crystals forming, they can damage the cells, they can dehydrate cells. It's not so good. So better techniques that have been developed are those that use something called vitrification, where essentially what you do is you add some antifreeze or cryoprotectants to things before you cool them down. And through doing so, you prevent the formation of ice, and you can get better survival rates for embryos and other material that gets stored. Now, that works really well for small amounts of biological material, like embryos and sperm and eggs. But the problem is it doesn't scale so well as you get to bigger and bigger things, whether that's organs or whether that's whole human bodies. And that's because the cryoprotectants, the antifreeze, itself can be a little bit toxic, but also it can cause dehydration. So if you look at the brains of people who've been preserved using vitrification techniques, you'll see that they've shriveled by something like 50%, which is really not ideal for a procedure that's supposed to preserve someone fully intact with the hope of being able to revive them in the future. But that's not the last technique that's been developed. And the one that I am most bullish about is a newer technique called aldehyde stabilized cryopreservation, which is a big mouthful. But basically, it's a technique that involves something called fixation. So the idea here is before you cool down a person's body, you can use preservative chemicals that you introduce into them, fixatives. And what they do is they infiltrate someone's body, they get everywhere, and they essentially lock everything in place, like all the molecules, all the structures, down to the nanoscopic, microscopic level. And in doing so, they prevent any decay of the synaptic neural connections that store someone's memories, personality, all those sorts of structures. And they ensure that everything that's critical to making a person who they are, all those structures, all that information stays intact for an indefinite period of time. So that's the long answer, I guess, to what techniques we're talking about when I talk about preserving individuals.
Okay, just so I imagine this better. So you say with this technology, I'm not going to be able to repeat it, we can preserve our brains, right? So let's say a person is terminally ill and wants to proceed with this procedure. What happens next? Do they need to remove the brain and put it in some sort of a vat with these chemicals? Or do they just freeze the whole body like, they did with the 60s when they, or whatever?
I'll run you through it. So I go through this at length in the book, and the short version is, what you would do is you would take someone who's terminally ill. Now, in most jurisdictions, you'd only be able to do this procedure from once their heart stops and they were legally declared dead. But at the point where just after someone's heart has stopped, what you would do is you would insert a catheter, essentially a big needle, into their heart, and you would then wash out the blood from their body and introduce these fixative chemicals instead. So this would permeate throughout their body and their brain, their entire circulatory system. And in doing so, the preservative chemicals would get everywhere and lock everything in place in that manner and ensure good quality preservation. What you could then also do is, once you've got the fixative in place, you could then introduce some antifreeze, cryoprotectants, and because you've done this initial fixation, you won't get the associated dehydration after. And that means you can then also store people at cold temperatures if you want, without having to worry about those issues as well. It sounds really gruesome. I understand that.
Yeah, it
does
a little bit, yeah.
I assure you all surgery sounds really gruesome once you start talking about the technical details.
But you said the heart needs to stop beating in order for us to be able to do that, legally. Wouldn't that defeat the purpose? Because that would mean that you have to be dead first.
So this gets into the definition of what exactly death is, which is also a fascinating aspect of this whole set of philosophical questions. And I think what really helps is a bit of a historical perspective when trying to keep in mind what it means for someone to die. Because it can seem really clear-cut, and we're always sure that doctors and lawyers and ethicists have a clear idea of when someone's alive and when someone's dead. But if you look at how the definition has changed over history, you can see it's actually much murkier. So, prior to the middle of the 20th century, doctors used to define someone dead just based on they'd stopped breathing. Because before that point, there wasn't really anything you could do for someone anymore once they'd stopped breathing. But then with the invention of things like mechanical ventilators, things that could breathe for people once their lungs had stopped, or cardiopulmonary bypass machines that could circulate someone's blood after their heart had stopped beating, it became clear that a definition of death just based on someone stopped breathing wasn't really going to cut it anymore. So in the 1970s in the US, there was the development of a new definition called, there was a new law developed called the Uniform Determination of Death Act. And what it did is it defined someone as dead based on one of two criteria. Either one, irreversible cessation of all heart and lung functions, or two, irreversible cessation of all functions of the brain. Now, that was better than the previous lack of any formal definition, but even at the time, it became apparent that there were issues with this newer definition. The first issue being that the technology for keeping someone alive even when their heart and lungs had stopped was continuing to get better and better. And nowadays we use something called ECMO, or extracorporeal membrane oxygenation machines, that are essentially able to fully substitute for someone's heart and lungs for a period of days or weeks by taking the blood out of someone, removing the carbon dioxide, introducing the oxygen back into the blood, and then returning that blood back into someone's body. So that's why nowadays we don't really think about heart and lung function being critical to a person being alive. We're much more focused on the brain functions aspect, which is the definition of brain death. But the issue with the brain death one as well is that in the same way that we've gotten better and better at developing technology which can replace the functions of someone's heart and lungs, we're slowly getting better at doing the same technology for replacing damaged brain functions. So there's examples where people have had spinal cord injuries and they've been given implants that can give them some control over their limbs again, or some control over their blood pressure. And there's newer, fancier implants that are helping people with language difficulties or other kinds of motor difficulties. And these prosthetics are continuing to improve. So the question is, if these things continue to evolve, if we continue to replace more and more damaged brain functions with machines, then what will it mean for someone to die when, based on a definition of loss of brain functions, if you can just always replace brain functions? And what some philosophers have said is that actually what we really care about when we talk about a person being alive or having died is not whether they can, grow their nails or beat their heart. It's whether they still have their memories, their personality, their goals and desires, all the psychological properties that make them them. That's what's important to still being alive. So to bring this back to your question about someone's heart stopping. So already at the moment, there's frequently circumstances where people survive having their heart stopped for a period of time. But we can legally define someone as dead once their heart is stopped. But we can do so even while their brain and all the structures in their brain that give them their psychological properties are still intact. So that's why I distinguish between the legal definition of death and what I think is actually the philosophically correct definition of death.
Wow. Okay, if we take this process further, like you do in the book, how would our descendants in the future, if they choose to do so, then revive or reproduce this kind of hibernating mind?
Yeah. So that's a great question, and obviously a speculative one. I try and stay mostly as grounded as I can in like modern neuroscience, modern medicine, but when we're looking to the future, we've got to have some guesses about what might happen. That's not to say I think it's complete guesswork and that there's nothing that can inform what I'm saying, but just to say that I am cautious when I'm guessing at what might be possible. So that being said, there's two main ideas people have in mind when it comes to future revival. One is mind uploading, the idea of taking someone's brain and somehow giving them a new artificial digital format based on the original biological brain. And the other version is just fixing the brain and body that the individual had directly through maybe some kind of nanomedicine or just much more advanced medicine than we have today.
Sorry, if I can interrupt just for a second. In the first option, do we mean like they just upload you into some sort of a very detailed and advanced version of Minecraft or something?
So yeah, let's get into the details. So there's all sorts of different ways you can imagine something like mind uploading, giving someone a new digital electronic brain could work. So I was talking before about the brain implants and prostheses that people have been given, where, for example, they have loss of a limb and they get an implant which can help them control a limb. Or when they have a bit of their brain is damaged, but they get given some implant that can replace what its functions were. You can imagine taking this to its logical extreme, where you have a digital or electronic version of a brain that perfectly recreates the previous functions of the biological brain on which it was based. So that would be called a whole brain emulation, where what you've done is you've looked at all 86 billion neurons that make up some human's brain, and you've looked at all of the roughly quadrillion connections that exist between those neurons, those synapses, and then you've recreated them in some format. Now that might be just digitally or virtually inside standard computing hardware that we think about in the memory of a hard drive. Or it could also alternatively possibly be in what's called a neuromorphic format. So that's a kind of still digital electronic format, but where the hardware is much more similar to what we normally think about with biological brains. But either way, you've taken the biology, you've scanned someone's brain at very high resolution, you've used that information to recreate their brain, and then you have to connect it up to some sort of sensory inputs and outputs, whether that's a robotic body, whether that's a virtual body, something that can give them back their vision and their taste and their feeling of having a body. That's the coarse-grained idea of what people have in mind when they're thinking about uploading.
Okay, this is all speculative, of course, but if we upload my personality and my memories and then upload it and bring it back online sometime in the future, wouldn't I just be a clone then? You know what I mean? Would that still feel like me.
Yeah, it's certainly like, it's not obvious that would be you, right? I share that intuition as well. But what I would say is when you take a step back, what it is that makes someone the same person over time ends up being pretty weird and complicated. And you can prompt this intuition almost immediately by considering the fact that you're not really even made of the same stuff that you were a few years ago, nor will you be made of the same stuff in a few years from now. So about every year and a half, you fully replace or almost entirely replace the physical material of your body through eating and drinking and breathing and having your cells change over, all this material change over. So the question is, like, what is it that makes you the same person today that you were a year ago, 5 years ago, 10 years ago, or will be in a few years from now? That's the question of personal identity. And what's interesting is that the question of personal identity comes apart from the question of what is it that makes you who you are in any given moment. So when you're conscious right now, when you're sitting at this computer, talking to me, feeling your chair, or listening to this podcast later, you're conscious in that moment. You have those experiences right then, but that's a separate question from what binds your experiences together across time. What makes your experience from a year ago or 10 years ago somehow be part of the same person that you are right now? Okay, so we got two questions. What makes you conscious at the moment, and personal identity, and how does this relate to whether you're a copy or not a copy? So you can go through it quite laboriously. You can go through, well, maybe it's having the same body. Well, that doesn't seem to work because we're made of different stuff over time. Or you can say, well, maybe it's about having the same memories or the same consciousness or the same personality. That, I think, is a better argument for what makes someone the same person over time. And indeed, if you look at all the different options available, I think the best answer to the question of personal identity, or what makes someone the same person over time, is that they're able to hold on to their memories, their personality, their goals and desires through the maintenance of the particular structures of their brain that encode those things. And if you accept that is what helps you survive over time, then it does have the weird implication that even if you change someone's brain into completely different format, if you switched it out from biological components to electronic components, or you transferred it over into a computer, that as long as the memories, the personality, all those things were still there, then that would indeed still be the same person, in the same way that I'm the same person, even though I'm not made of the same stuff I was 10 years ago.
Yeah, I wanted to answer with like, oh, of course, it's the continuity of self, obviously, but that's even murkier than,
so
personality.
we got to be
but personality
careful.
Does change, like everything.
Yeah,
else.
it does and it doesn't. So like people's personalities are actually quite stable across their lifespan. You can like ask people the same questions, or how would you react in these scenarios at different points in their lifespan? And they're much more similar to themselves over time than they are to the answers that other people give. Like if you're an extroverted person now, you'll probably be an extroverted person in 20 years from now. And if you're an anxious person now, you'll probably be an anxious person in 20 years from now. But I just wanted to note that what the self is and what, consciousness is also aren't necessarily the same thing. In that, it's definitely not the case that we have an unbroken stream of consciousness over our lifespan, where, we go to sleep at night and we're maybe unconscious for a time, or we undergo anesthesia and we're almost certainly unconscious for a time. Or even more radically, there's an already existing procedure that's used today where we induce hypothermia in people. So this isn't the brain preservation stuff. This is what they use in surgeries all over the world today, where what they'll do is they'll take a patient, they'll cool them down to like 18 degrees Celsius or so. Their heart will stop. Their brain activity will stop. They'll look, for all intents and purposes, like a corpse, but it gives surgeons an operating window where they can operate on the blood vessels around someone's heart, or the delicate blood vessels in their brain that they wouldn't otherwise be able to operate on. And it gives them like 30 to 45 minutes to work before they then warm the person back up again and they're restored to consciousness. And somebody definitely wasn't conscious during this period of time. They didn't have any brain activity or really anything that could sustain consciousness, but they definitely survived this, meaning the self can survive even periods where consciousness isn't there.
If I forced you to risk a prediction on when we would be able to achieve all of this, preservation, scanning, reviving, etc. What would you say?
So there's a difference between my view and what I think the like community of neuroscientists would say. So I'm slightly more optimistic. I look at extrapolating the history of computing performance, and I think about, so a brain maybe has something like, we know it has about 86 billion neurons. We know it's got about a quadrillion connections. We have an idea that we could model those things with maybe like each neuron could be modeled as like 10,000 different compartments interacting with each other. And you could put these sort of numbers together and get a guess at like what amount of computing power would be required to create like a digital version of a brain. And then you can look at like how computing performance has been improving over the years. And you see things like, I think we've had 100 million increase in computing speed since the 1990s to today. And if you think there's a chance that that will continue to hold, that Moore's law will continue to hold, that would give you an estimate of maybe we could produce an equivalent digital version of a human brain sometime in the late 2040s or early 2050s. But that's assuming everything went right, and it never does in science. So probably at some later time point than that, maybe towards the end of the century.
Gosh, I'm
but actually,
miss it. Yeah.
I did a survey of neuroscientists recently, of like randomly selected neuroscientists, asking them these sorts of questions, being like, when do you think the first whole brain emulation of a human would possibly be created? And the average response I got from people was about 21, 25, I think. So sometime early in the 22nd century. Now, these are all sort of ballpark numbers. I wouldn't put too much stock in them. I wouldn't be putting big bets down on like, this is the precise year. But that's sort of the vague numbers people have in mind for when these things might become possible.
I just got a terrible idea. What if this actually happens, but then people in the future decide, for example, that I was a total piece of shit or something, and then they just upload me in some nightmarish scenario, like the final level of the video game Doom, which is basically in hell or something. You know what I mean?
Yeah. So there's plenty of sci-fi stories that sort of explore these hellish possibilities. And like, they're obviously impossible to completely dismiss the idea that that might be something that happens. Because if you're saying this technology is possible, then it enables all sorts of scenarios. But my response would be it's very strange to imagine a world in which someone would go to the bother of preserving you, of maintaining your preserved body for all this time, of working out how to revive and upload you, of restoring you to consciousness with all the expense that it would take to do that, to then just decide to like torture you. I think in almost all circumstances, if people like don't care about you, they're just going to let your body rot or like not do anything. And the default state would be, just to leave people in preservation or let them decay. I think what's actually much more likely is the only circumstance under which anyone is getting revived is if our descendants look at the world in which they live in and they see that that world is a better world than the world that we live in today, that we've solved climate change, we haven't destroyed ourselves with nuclear war, we've solved poverty issues, we've provided wealth and prosperity to everyone, and they think, you know what, this is actually a pretty good world to live in, and like maybe it would be a fun challenge to try and revive our ancestors and let them share this world with us. I mean, that's why I called the book The Future Loves You, because this is the sort of thing I think we should be working towards. And I think it's the positive vision of like the kind of future we would like to live in is one that would be good for our descendants and then hopefully also good for us. Because in the same way, like there's plenty of terrible things that exist at the moment, whether that's climate change, conflicts, inequality. But if you take a bit of a historical perspective and you look back at the fact that like 200 years ago, 1 in 2 children died before they were 15. Most people lived in extreme poverty. There was considerably more violence than there is today. Women were oppressed. We still had slavery. Like, it's not that the world doesn't have problems, but it's getting better. And I hope that it will continue to get better in that way.
Mm. So sort of like the Star Trek scenario where we overcome all these issues. But I don't know. I'm just imagining, since we're still very tribal, that in the future, if the conservatives have this technology, they're just going to revive the conservatives or vice versa. This sort of scenario. Let's just revive the people that look like us or think like us.
Well, there's all sorts of scenarios you can imagine. I mean, I think the default state, so we can imagine I mean, I think there's a reasonable chance, unfortunately, that like the world does get destroyed or ends up impoverished or we don't end up producing a flourishing future. And if that scenario comes to pass, then none of what I'm talking about is going to work. So already we're assuming, at least some groups of people have enough wealth and prosperity to be able to create the sorts of technologies I'm talking about. Then in that scenario, there's the question of like, well, how expensive will it be? Who will it be distributed to? Will it be distributed to everyone? And even if it is to everyone, with what time cost? Like who will get it first? Those sorts of things. What I imagine though is like you can look around at medical technology we have today to give you maybe some hint of how it will go. Where certainly there's things that are very expensive and very unequally distributed. Things like very expensive cancer therapies that only rich people in Western countries have any hope of getting access to. And that's tragic that more people can't use these who need them. But the general trend with all these medical technologies is, we mentioned insulin before at the start of this chat. Yeah. So Elizabeth, one of the first people to get insulin, she only really managed to get insulin because her dad, I think, was the former Supreme Court justice, maybe a former vice president of the United States.
Well,
so she was really on the short list for getting it. Yeah. So in 1919, 1921, that's what you needed. But today, a century later, basically everyone with diabetes has access to insulin. And in most places in the world, it's quite cheap and affordable and readily accessible. And that's mostly what we see for all medical technologies, where they start off being restricted to particularly well-off groups, but then they become easier and easier to access and more broadly distributed. And that's kind of what I guess would happen with this sort of revival technology as well, where maybe initially it's only used for those who have connections and money, but hopefully would become accessible to everyone over time.
So suppose the future goes your way and we start doing this preservation en masse in the hundreds of millions. Where would the future humanity put all of these confused ancestors?
Yeah. Well, there's the question of like, what do we do with people we preserve today? And there's what do we do with people once we revive them in the future? And so the first thing I would say is like, it seems like a lot of people, I think it's like, I'm going to get the exact number wrong, like 70 million people or so die every year at the moment, which is quite a lot of people, but people actually aren't that big. And we could fairly easily warehouse that number of people per year in an ongoing effort. It would cost a reasonable amount of money to do so, but an amount of money that's, a few percentage of pre-existing healthcare budgets typically. In fact, like we talk about a lack of housing and a lack of land, but I think it's only something like 1% of all of Earth's surface, like land mass, is currently built up on. So there is space for this sort of stuff. And you don't need prime real estate for warehousing bodies that are just preserved for a long period of time. But then there's the question of like, what do you do with people once you revive them? And then it like really depends on the technology you have in mind. So if you live in a world where, there is too many people, not enough space, not enough money, they're probably just going to not revive people. They'll leave them in the warehouses. It's only a world in which either we've worked out how to produce enough space here on Earth, or space travel has gotten cheap enough that, there's plenty of land up in the stars these days, or where we've worked out how to do uploading and people can live in digital formats, taking up very little space, that I think anyone's going to start reviving people. Because the great thing about preservation is if our descendants don't have the resources to do it at the time, they can just leave people preserved until they do.
Speaking of confused ancestors, here's my last gripe with the idea. Technological progress, like we talked about, seems to have gone light speed ever since the scientific revolution happened. And if anything, it's only speeding up as we go along. Which means that 250 years from now, let's say, the world would be unrecognizable to us living here in 2024. Don't you think someone who's revived a quarter of millennia from now would basically just immediately become either severely depressed or maybe even insane due to kind of like shock and this insanely intense feeling of alienation?
I have no doubt that the future, no matter what happens, will be extremely weird. So I agree with you on that one. Again, to pull up historical analogies, in the same way that if we took someone from the 1800s who was, a peasant farmer into today's world of supermarkets and aircraft and TikTok, they'd be like, what is going on? They'd be so confused. But that being said, I think if they were given supports to adapt to the language, to work out what was happening with technology, then they may well live, despite a period of confusion, a still satisfying life once they started to adapt. And we can see sort of analogous circumstances even today, when occasionally there are people who've come from war-torn, developing, impoverished countries into rich, developed first world countries. And when these people are given language classes, when they're given technology classes, when they're provided some sort of social community integration, typically they do describe having very high life satisfaction, particularly if they're able to, take their friends and family and escape with other refugees with them. So I imagine in the scenario I'm talking about, we would all be as temporal refugees, would be arriving very confused into this future world. But again, my hope, and this is optimistic, but I think not entirely unrealistic, is that if our descendants bothered to revive us, they'd probably bother to help us integrate as well.
Okay, I want to switch it up and just ask you, what do you think personally would be a good number of years to have? Like just in general as an idea. Should we put a cap on it? Are we talking 150, 200, 1,000 years? Or just basically an indefinite life if no accidents happen or something? You could basically end whenever you wanted to.
Yeah, I mean, the short answer is I think it should always be up to the individual. Like choices of health and lifespan should, as much as possible, be for individual people to decide. And if they want to live 150 years and no longer, fine. If they want to live 80 years and no longer, that should be up to them. But it's really a matter of giving people choices. Now, it might seem to people who are in their 20s and 30s and 40s that when they get to their 80s, they'll be like, well, I've done everything I set out to do and I'm finished with life. But if you actually go and you survey those who are terminally ill, you go into hospices, you find people who are sadly dying of cancer, and you ask them, like, what is your will to live? What you will see is that I think something like 70% of them in surveys that have been done still describe having a very strong will to live. And I think that's because for most people, whether they're 80 or probably even 100 or 120, if you give them the option of another day in the sun with their relatives and some music and some ice cream or whatever else they enjoy, or if you give them more time to pursue their goals and their passions, people would generally like to live longer lives than we currently do. And like you can compare to some other animals where there are tortoises and whales that live for something like 200 and 250 years. And that seems like a better amount of time. Or you can look at darker versions where our ancestors lived something like 40 to 60 years. And that certainly seems like too little time, I think, to most people today. But the short answer is, yeah, I think people should just be able to choose for themselves.
Well, speaking of years, why are we hardwired to only live about 75 to 80 years? Seems quite random. Although I guess any number would seem quite random, to be honest. But you mentioned whales, for example. I just read that they recently found a Greenland shark who was 400 years old, 392 years old. Hardly fair, isn't it?
Yeah, I mean, it's a question we don't think about very much. We normally just think, humans live for 80 years, dogs live for, I'm going to get this wrong, I'm not a dog owner. Is it like 7 to 10 years or something?
It depends on the breed, but it's up to 15. Yeah. It sucks. Yeah.
Yeah, mice only live like 1 to 2 years. And then there's these like whales and sharks swimming around for centuries. Like, what gives? How come we don't get to live that long? Essentially, what it comes down to is an evolutionary trade-off between how quickly animals of a species can start reproducing and how likely they are to be killed by their environment. And it has to be this trade-off because actually what would be evolutionarily optimal would be an animal that had really short reproductive cycles, that bred all the time, and was also immortal. It never died. Like that would be a perfect organism. It would just like continue breeding, continue breeding, continue breeding. But you can't do that. There's no way evolutionarily to design that. So what ends up happening instead is a trade-off between making something start breeding quickly and not really caring about how long it's built to last, or building something to last a really long time, but making some sacrifices on how long it takes to start breeding. And this essentially comes down at a genetic level to choices that are made with individual genes and individual variants of genes that affect a whole bunch of different things. And you have to calibrate them I say you, but evolution calibrates them either a bit more towards living longer or a bit more towards shorter reproduction. And the thing that really applies the pressure is how likely that kind of animal is to be killed by its environment. So for example, if you're a little mouse, you could build a mouse that like didn't age and that had slower reproduction, but something's going to step on it, or a cat's going to kill it, or a snake's going to kill it in a pretty short period of time. So there's not really any reason to build a mouse that could theoretically live to 50 years if it's just going to die from from external causes within a few months anyway. But on the other side, if you're a giant whale, like until humans invented harpoons, basically nothing could kill you. So it made sense to build it so that it didn't get cancer, it didn't get heart disease, it just lasted a really long time. And so it doesn't matter if it, doesn't stop breeding until it gets to 13 or 15 or something, if it's going to live 200 years afterwards anyway. So that's where it comes from. So with humans, we live 80 years, which is pretty good for most species, basically because we are pretty good at sticking around for a while and not being killed. But we still, compared to whales, have some significant sources of things that kill us. And the two things historically that did that, one was infections, getting cuts or pneumonia or any of those sorts of things. And the other thing, sadly, was other humans, where I think historically we had something like a 15 or 10% rate of homicide or being killed by other people. So yeah, that's why we live 80 years.
Yeah, it's fascinating how it's all a matter of perspective. Like you said, when I was 19, I was like, 80 years, what am I going to do with all this time? Jesus Christ. And now, and I'm almost 40, I'm like, what the hell? Only 80 years? That sucks.
A common experience, I think, for people.
Yeah, but it's when you're explaining how it works, it's so brutally functional in a way. So in a nutshell, the more dangers there are out there trying to kill us, the shorter our reproductive age, the faster we die. Is that it?
Yeah, pretty much. I mean, like nature and biology is like beautiful and fascinating, but it is also extremely cruel. Like evolution doesn't care about anything except inclusive fitness, reproductive ability, and it'll sacrifice years of people's lives or health or anything if it will slightly improve fitness. And it's pretty horrible.
I watched an interview you did for another podcast discussing your book, and most of the comments underneath basically kind of coalesced around the same idea. And there was people saying, by the love of God, I don't want to go to work for 200 years more, and I just want to live a better, not a longer life. But I guess those two aren't mutually exclusive necessarily. However, there seems to be the idea that people want to live in a much better world first before we begin talking about living drastically longer lives.
Yeah, it seems a little odd depending on how you ask the question. You get different answers from people. And I even am not entirely sure how to square this all together yet. So I have heard comments like that. But what's a bit odd is if you also ask people, how satisfied are you with your life? Or is your life worth living? Most people, at least in developed countries, actually say, yes, my life is worth living. I think out of a score of 1 to 10, where 1 is not good at all and 10 is the best, people in Europe and the US and Australia typically give something like a 7 out of 10. That doesn't mean everyone. Some people, sadly, don't have great lives for all sorts of psychological, medical, social reasons. But the typical person does say and does think that they have a good life. So even if all we could offer people was a continuation of their current existence, but for longer, I think many people would quite like to take that up. But that being said, also, I agree with them when they say, we should be working on producing a better world and like focusing on that. I just don't think they're exclusive. Like in the same way that we should be trying to ensure that wealth is distributed to more and more people instead of captured by an elite. In the same way, we should be trying to cure diseases that are still afflicting people. We should be doing all of those things at the same time as improving living standards and improving working standards for people. I don't think you have to choose one or the other.
Since I can only relate to these things in like trashy pop culture terms, have you seen the movie Elysium? It's a sci-fi starring Matt Damon, where the oligarchs, the elites, live on like a private moon, where they have the technology to live endless and endlessly healthy lives, while the rest of the folks live in squalor in these sort of giant favelas on Earth. This also seems like a pretty plausible scenario, no?
I think if we had a world in which we developed some sort of anti-aging medicine, but it costs like $50 million for it to work, that'd be really like dire. We'd still I still think it would be good to have something that we could work on making cheaper, but we would be dealing with these really difficult ethical questions of like, how can we ensure access? Is this equitable and fair? I guess, unfortunately for billionaires, but fortunately for everyone, I don't think that's going to happen anytime soon. And my proposal is much weirder, where I'm saying I don't have a way to keep only billionaires alive for centuries. I think we have a preservation technique that has an enforced period of stasis, but which could actually be done fairly cheaply. So like my estimate is something like $10,000 per procedure to preserve someone, and maybe a few $100 to $1,000 a year in storage costs if these procedures were provided at scale, which is well within the sorts of surgical medical costs that are provided to people generally, again, in Western developed countries. So it's not the case, I think, that in the near term we're going to be seeing only these sorts of things being available only to the super rich and everyone else just left to die. I think the main constraints are, do people actually want to take up these sorts of preservation technologies? Not, will they be able to afford them? That's separate to the revival. Like, I think revival might be quite expensive at some point in the future, and more like other things where it starts super expensive and then gets cheaper. But again, the great thing is, as long as someone's preserved, they can wait until it becomes cheaper.
Yeah, also, what's cool about this idea is that if we do become a better society or better humans in the future, they could choose individually who to revive and who not to revive. And they would basically say, oh, this person was really cool. They weren't just like, hoarding wealth. Let's revive this person. And maybe, billionaire, we don't have any more use of these.
This is an idea I speculate on in the book where I hope that future generations will be better people than we are today. In the same way that, we don't have slaves, we're nicer to women. We generally, despite our flaws, I think, nicer to animals in the world than we were in times before. There's still a lot of improvements that we could do. And I hope that people a few centuries from now will look back on us and be like, yeah, they did some pretty hard stuff, but, we're graceful and kind and generous, and we'll revive them regardless, particularly if we've done a good job of improving things. But I definitely think it's the case that, if you're the sort of person who contributed to making the world a better place in the future, if you're one of the people who did nice things, solve problems, otherwise overcome the difficulties and challenges of our time to contribute to advancements, maybe you get bumped up the revival list or something. Who knows? But this is very speculation.
All right. I want to talk about the more quote unquote philosophical implications of potentially living forever. What do you think would happen to our very nature if we did end up being I know you don't want to use that word, but please humor me. Basically immortal. Would we still be humans, or would we be something else?
I mean, it again depends on what you define as core to being human. If you mean that to be human is to have, the particular genetic makeup that makes up a human cell and differentiates a human cell from a chimpanzee cell from a mouse cell, then I guess if we start messing around with the fundamental building blocks of what we've made of, arguably we wouldn't be human anymore. But I don't think that's what most people think or really care about when it comes to being human. In the same way that I don't think somebody thinks they're a different person if they get a prosthetic implant, whether that's false teeth or an artificial heart or any sort of artificial device. I think what most people think is core to being human is, having love for one's friends and family, experiencing the world in the particular way they do, or having particular tastes or musical preferences or professional goals, those sorts of psychological things. And I think that if revival is successful, the only way it could be successful and it could really bring a person back would be if it held on to those things which are core to making people who they are. And in that sense, I'd say that people would still be human, or at least this wouldn't work unless it kept that part of our humanity.
I guess I was maybe asking about a sort of existential motivation that is derived from the awareness that, the number of years on this earth is limited. to us. So we better do something useful or meaningful while we're here. With this removed, would we still care about anything?
I mean, I don't think most people really go about their lives and are motivated to action because they're worried that in some time period from now, they're going to die. Like, when people are going to a party, I don't think they're like, well, I've only got X many parties left before I end. Or when they go for a promotion, I think they're more motivated by proximate goals of wanting to achieve things in the meantime or enjoy a particular day or a holiday in a shorter period of time. That's not to say people don't have goals that take years or decades to complete. But again, I think it's the goal itself that mostly is what's motivating people, rather than the knowledge of there being a deadline at the end. And I think this becomes a bit obvious when you think about the fact that, if we knew that we live for 200 or 300 years, I don't think that would put people off from doing things at the moment. Maybe on the margin, it might make them procrastinate a little bit more. But I think for the most part, people already procrastinate today, knowing that their lives are short. And a lot of people get a lot of stuff done with no regard for the fact that it's because they're going to die.
So I suppose you don't believe in this Freudian death drive, that basically deep down we all want to die at some point. I imagine, especially if we indeed have lived healthy, full, and meaningful lives.
No, it both doesn't make sense to me on a personal, emotional level. I don't see the argument for it at a philosophical level. And it would be a very weird thing to evolutionarily program into an animal, to have it be okay with or even strive for its own eventual death.
What do you think would happen to relationships if you were married to somebody, or I don't know, friendships even, that you're like, oh damn, I have to spend the next 500 years with this person now. Like it would change pretty much everything when we talk about
I think it would get
time scales.
Sorry, I keep interrupting.
No,
I think it would get complicated, but probably better in a lot of ways, despite being weirder. I mean, I think about people I've been friends with since I was a child. And I used to have, maybe when I was at school, much stronger and more frequent interactions with. But nowadays, I still have very rich relationships with these people, even if it's one of my best friends who I only see every couple of months or every 6 months these days. What I imagine is you would start to develop many, many more of these sorts of things, where there'd be people who'd be really intensely part of your life for a period of time, and then you might drift apart for a while, but you'd still hold on to these strong connections to people. That would be my guess in one sense. And also, there's already relationships today, whether it's people who have family members, whether that's your brother or sister, or a child or a partner, where it doesn't really seem like over the years and decades, people get sick of each other or want to stop spending time with each other. I haven't really come across a parent or a grandparent. Well, I shouldn't say haven't, but most parents or grandparents are still quite happy to see their kids and grandkids, even if it's for the 100,000th, 10,000th time. Now, there's a more complication, I admit, when it comes to, romantic relationships.
I suppose
many couples
are the question.
Well, I think that's up for each couple to decide. It works well for some people. Perhaps it would become more strained for others, and that would be complicated. But I think it's a much nicer problem to have than the one of it being till death do us part, which is what we have at the moment. Better they have to talk about it again in 50 years or 100 years from now.
Do you think there's some sort of a hard drive that we have a limit when our brains are concerned of how much information we can retain? If we do end up living for 500 years, would you be able to remember things or basically process new information, or would you just be oversaturated and overwhelmed by everything that's happening all the time?
This is a fascinating question, and I think unfortunately one that we really don't have a clear answer to as of yet. But I'll talk through how one thinks about it. So we know, as I mentioned before, a brain has something like 86 billion neurons and a quadrillion connections. So a huge number of connections, but still a finite number of connections. It's not expandable at this point in time. So there's presumably only so much you can pack into it. But what we don't know is what is the limit of what can be packed into it? Because it could well be the case that a lot more that can be packed into a human brain than ever actually fits into it during a typical human lifespan. Because it's not the case that people die because, their brains are oversaturated and their memories are falling out in the end. typically people get cancer or heart disease and die before those limits get reached, whatever they are. Even in things like dementia, that's not being caused by people's brains filling up. That's called, we don't really know what the cause is, but we know that it's associated with synapses, brain connections being destroyed, and then the neurons themselves actually dying. Not that like there's too many connections forming and somehow it stops functioning. So the question is like, well, actually, maybe you could pack 150 years, 200 years, 500 years worth of memory in there. We're not sure. Certainly, there's other precedents of human brains being able to do amazing things that you wouldn't have been able to predict ahead of time. So some obvious examples being, our ancestors would only have met a few hundred people in their lifetime back if you lived like 500,000 years ago. So they wouldn't have had to recognize that many faces. But it turns out that like humans today can end up recognizing thousands and thousands and thousands of faces. So a much greater capacity was built in than what was actually needed. And there's other cool things like we're able to read, even though reading is only something that's existed for a few thousand years. Essentially, again, because of like spare capacity in our brains compared to what was, evolutionarily designed for. So my guess is it would be you could store a lot more memories than typically fits into a human lifespan, even if maybe it starts to become a problem at some point, and then we'd have to work on brain implants, other solutions to that problem once we got there.
So this sort of neuroplasticity could be potentially endless. But I had a high school reunion recently, and while I did remember the faces, I can't remember like the last names, even though it was like, 19 years ago. So
yeah,
I don't know. I'm a little bit skeptical. Maybe that's just my poor cognitive performance.
No. We do obviously forget things. We do tend to forget things that are less important and less salient to us. We discard mostly information that is less meaningful, and we hold on to the things that are really core to us. So it's not that there's nothing lost, and it would be great if we had means of preventing those sorts of losses. My point is just that like we can pack a lifetime of experiences in. Elderly people outside of cases of dementia typically are able to recall a truly staggering number of memories and episodes from their lives and amounts of material that they've recalled and remembered. And my suspicion is if we were able to get around these other health issues, even typical human brains could store a whole heap more than they are currently able ever get to.
At the end, I just had another horrific kind of thought. I personally don't believe in it, but I hosted Dr. Bruce Grayson, who's studying NDEs a while back, and he's sort of
near-death experiences.
Exactly, yes, and he's sort of convinced that there is something after death. Wouldn't kind of be tragic if we did end up living forever, end up being almost immortal, and then denying ourselves the chance to experience the afterlife if it does exist, and it's just like an amazing endless party or something? Would be ironic in a dark sort of sense.
Absolutely, that would be tragic. I just think the evidence for an afterlife is not particularly strong.
Yeah.
Insofar as people have not proposed clear mechanisms through which something like that could really work. I mean, if it is the case that, for example, humans have souls, and when a person dies, the soul leaves the body and goes to the afterlife, I guess what I would say is I don't think the preservation techniques I'm proposing would be able to bind someone's soul. Like, if it's an immaterial soul, then the preservative chemicals presumably aren't going to hold on to it. So you'd still get to go to the afterlife. But from what I can see is arguments involving souls or sort of spiritual dualistic accounts of what it is that gives us our consciousness, makes us who we are, don't have a lot of explanatory power at being able to say why it is that someone's memories or personality changes when they get a head injury, or why it is that we lose consciousness when we undergo anesthesia or are hypothermic. These things seem much better explained by suggesting that what is core to being a person is having particular kinds of brain activity in the particular structures of our brain. And the flip side of that is if that activity stops permanently or those brain structures are destroyed, then there's pretty strong evidence to think that a person's just gone forever from that point onwards.
Yeah. I did tell him during our interview that I did undergo anesthesia and there was just like an absence of everything. So I was like, okay, that's it when you die. It's probably...
Yeah.
But his argument...
That's exactly what I think happens.
Yeah. But his argument was more in the line of like our brain being a receiver of some sorts, you know? So if you damage the receiver, of course, you're not going to get a clear picture.
Yeah. I mean, so like, I understand what I'm proposing sounds super weird, and people are probably really skeptical of what I'm saying. So I encourage skepticism. And I would say that, like, if you have really weird claims, like my brain preservation ones, or this guy's near-death experiences due to spiritual connections to souls or something, I don't want to necessarily just like completely dismiss things out of hand just because they're weird. But what you have to do is you have to say, like, this is how my argument could be proven or disproven. Here's an experiment that you could run. And I know that because people have tried running experiments with these near-death experiences, that there doesn't seem to be much experimental evidence to back them up. I think the most famous one is there's this proposal that like people would ascend out of their bodies during near-death experiments.
Put some object somewhere. Like
yeah, and so they put objects up. They asked people if they could like report the objects that they saw, and nobody's been able to show that that happens. So that's sort of experimental falsification of the claims to a degree.
Ariel, thank you so much. I can't recommend your book enough. Who knows? Maybe I'll see you in the year 225 where we're both like revived in our sexy new bodies or minds or whatever.
Yeah.
And we'll do this interview again then. We're gonna be like,
I'd love to see you and all your listeners then.
Thank you so much. Last
Thanks
thing,
for having me on.
Do you have social media where people can see what you're up to these days?
Yeah, I've got Twitter, which is Ariel _ZJ, and I've got Bluesky, which is Ariel ZJ, and I've got a whole bunch of like YouTube interviews and print interviews. If you go to my website, arielzj.com, everything's linked from there.
Awesome. And where can people get your book? Find bookstores everywhere.
Amazon, bookstores, anywhere. Just have a Google and you'll be able to find it.
Awesome. Thanks again. This was an absolute blast.
Thanks. It's been a pleasure to be here.
Please subscribe to the podcast on YouTube, follow on Spotify and Apple Podcasts. I've been told I have to say that, otherwise nothing happens. Weird. Also, if you feel like it, support me on Patreon. This is a one-person pod. I do everything myself. There's no team behind me, so please feel free to hop on Patreon and find smart cookies on there. And then last but certainly not least, I have to thank my existing patrons. Tovarishi and Tovarishice, you legends, you. Without you, there would be no pod. Which makes you actual producers of this show. So eternal thanks to Juž Premrov, Nate Sirk, Goran Ivasic, Anje Sever, Ole, Marin Ferrara, Aljaž Maher, Strole, Aida, Mancian, Miha Medved, Medinho, Goran, Gordon, Lorenzo, Jurečuk, Mila, Carmen, Veronica, and Taichi. Seriously, I'm touched. Thank you so much.